Alright, so I just organized like the code steps that we need to do to interface the accelerometer and the magnetometer. So again, the fix is that the SPI mode is 0, not 3. And we're going to go ahead and test if we're connected with the accelerometer and the magnetometer. So we're going to go ahead and read the who am I register, which has address code 143, and check if it responds back. So it should respond back to 73. If it doesn't respond back to 73, then something has messed up. Okay, and then we're going to go ahead and write to the first control register to 103. That'll set the accelerometer sampling rate to 100 samples per second, enables all the axes to be read, and turns on the accelerometer. And then we're going to write to the second control register, and what we're going to do with that is we're going to go ahead and set the accelerometer sensitivity to plus minus 4 Gs. Then we're going to go ahead and write to the fifth control register, and by manipulating the fifth control register, we'll be able to set the magnetometer sampling rate to 50 samples per second. Then we're going to go ahead and write the sixth control register, and what that's going to do is it's going to change the magnetometer sensitivity to plus minus 2 Gauss. Then we're going to write to the seventh control register and set it to 0. And what that's going to do is it's going to allow the magnetometer to continuously read in data. And then once we have all that initialized, we're going to go ahead and read data from the accelerometer and the magnetometer. And so we're just going to first read 2 bytes of x-axis data, then y-axis data, and then z-axis data for the accelerometer. Then for the magnetometer, we're going to read the x, y, and z-axes as well. And then we're going to go ahead and output that data to screen so we can actually see it changing. And we can go ahead and just move the chip around and expose it to a magnet and see what happens. Alright, so now we're going to also connect this up to the accelerometer and the magnetometer. So first off, as you can see, the data out pins, there's one for the gyroscope and there's one for the accelerometer. So you want to go ahead and connect this together so that the master in slave out pin on the microcontroller is connected to the same thing. Okay, with that we're going to go ahead and select some arbitrary chip select pin. So I would go ahead and just say something that's close to here, and we'll call it PTC3 is what we'll use. So PTC3 is what we're going to use as the arbitrary chip select pin for the accelerometer and magnetometer. And we're going to go ahead and connect it up here. So that should be right over here. That should be it. Okay, so I went ahead and just wrote the comments and put it in here so we have something that we can work with. And I just went ahead and just instantiated the SPI class. Also, I instantiated the chip select pin for the accelerometer and the magnetometer, and it's PTC3. So let's go ahead and just start with the initializations part. So we're going to first test if we're connected with it. So again, we're going to go ahead and read to the who am I register. So first off, before we even begin, we want to go ahead and set the chip select pin on the gyroscope to 1, so to mean that we're not going to be talking to the gyroscope, and instead we're going to be talking to the accelerometer. Okay, I'm just going to go ahead and wait a couple of microseconds just to let it settle. Alright, so we're going to go first to SPI.write. This one, it says 143. And then I'm going to go ahead and read out what that is. So I'm going to say int who am I value is equal to SPI.write 0. And then we're going to do a quick test right here. So I'm going to say if who am I value equals 73. We're going to go ahead and print out that the accelerometer and the magnetometer were initialized or are connected. And then if not, I'm just going to say that failed to connect. Connect to the accelerometer and the magnetometer /n. Okay, so that's the initialization. I'm not going to go and test this because once I go back to the sketch, what's going to happen is that it's going to print this out first, and then it's going to print out the other values afterwards. So I'm going to go ahead and initialize the accelerometer and get a head start on that. So again, before I actually start here, I want to go ahead and terminate the communication. So I'm going to say Accel CS pin is equal to 1. I'm going to wait a couple microseconds. I'm going to wait 3. Okay, so this one is going to be, we're first going to again pull the chip select pin low. We're going to wait for it to settle down, because sometimes there's some jitter here and there. And then we're going to do SPI.write We're going to want to write to address code 32. Whoops. And then we want to write 103 after that. And we're going to wait 3 microseconds. And then we're going to go ahead and pull this up high again, just to end the SPI communication. Okay, so that's it for the first part. Now let's go ahead and do the second part, which is pretty much the exact same thing, but again, with a few small changes here and there. So all I have to do is I need to write to address code 33 and change it to 8. Okay, wait 3 microseconds and set it back to 1. I'm going to copy this again and then write to the 5th control register. So that means I want to set it to address code 36, and this is going to be set to 16. Okay, the next one is pretty much the same thing. So address code 37, I want to write 32 to it. Okay, next one. We're going to write to control set register 7, so the address code is 38. So let's change that to 38. We want to write 0 to it. Okay, and I think that pretty much covers the initialization steps. I already wrote here while true, just so we can continuously read data in. So we're going to go ahead and read 2 bytes of acceleration data on the x-axis. So I'm going to go ahead and set the accelerometer chip select pin to 0 again, just to pull it down low to initiate communication with it again. Then we're going to go ahead and do SPI.write. Oh, actually, wait, before we do that, we're going to wait a couple of microseconds just to prevent any sort of jitter that might negatively affect the communication. Do SPI.write and 232. And then we're going to go ahead and read 2 bytes in. So short, we're going to say Accel x-axis low byte is equal to SPI.write 0. I'm going to say short Accel x-axis high byte is equal to SPI.write 0. And then we're going to do what we did last time with the gyroscope data, so we're just going to go ahead and do the bit shifting operations. So this is Accel axis high byte, shift up by 8, or bitwise or Accel x-axis low byte. And then we're going to go ahead and wait 3 microseconds before we end the communication. Equal to 1, so that ends it. Okay, and this is pretty much the same thing for every single case. So I'm going to go ahead and just copy paste that right there and change this to 234. And we're going to call this the y-axis because we're reading from the y-axis data. Now we're going to read from the z-axis. So it's pretty much the same thing, but the address code is 236. And then it's z-axis. Right, so that pretty much covers it for the accelerometer data. Now we're going to go ahead and now do the stuff for the magnetometer. And again, it's pretty much the same thing, but all I have to do is just change the address codes. So it's pretty redundant, yes. That's kind of how this communication line is, especially when you have a lot of different registers. Okay, so I'm going to call this, instead of Accel, I'm going to call this mag x-axis for the magnetometer x-axis data. Mag x-axis is equal to mag x-axis high byte and mag x-axis low byte, and that should do it for the magnetometer. For the x-axis, just go ahead and copy paste and put that in here. This is 202. This is the y-axis. Okay, that should do it for the y-axis magnetometer data, and then the last one, finally, the z-axis magnetometer data. So copy pasted that there. The address code is 204. I'm going to call this magnetometer z-axis. Right, so you pretty much have now all the data from the accelerometer and the magnetometer. So let's go ahead and print all that stuff out. So I'm going to say do printf accelerometer x. I'm going to print out the value in the x-axis, %e for the y-axis now for the z-axis data. And then I'm going to do just do a semicolon just to separate the two. I'm going to say mag for magnetometer, and then I'm going to say the x-axis data, the y-axis data, and then the z-axis data. And then create a new line for each new data point, and then I'm just going to say Accel x-axis. Let's go ahead and just copy this. Then this is y-axis, this is the z-axis, this is the magnetometer data, so this is mag x-axis. Go ahead and copy this. Magnetometer y-axis, and the magnetometer z-axis. So what it's going to pretty much do, it's going to get this data and put it in here. So every time you see a %d, that's just a number based off one of these arguments right here. So what it's pretty much do is it's going to really print out the accelerometer data and the magnetometer data, and I don't want to make it so that it reads out too quickly so we don't actually get a chance to see what numbers get popped out. So I'm just going to make it wait half a second before it prints out again. And that should be it. I'm going to go ahead and compile this. I'm going to go ahead and upload it, and we're going to see the output. Okay, so I just uploaded the code onto the microcontroller, and let's go ahead and connect with it. So you can see that it's actually collecting data right now. Let me hit restart. So just so we can actually start from the beginning. So restart. Okay, so it's connected. As you can see, the accelerometer is outputting data. The z-axis is the it's where it's facing toward the Earth, so you can actually use the larger value because it's actually picking up the Earth's gravitational acceleration. The magnetometer has some strange values for some reason because it's probably picking up the nearby magnetic fields. It's also sensitive to metal as well. And then let me go ahead and grab this kitchen magnet over here. Just put it in front of it. If I put it in the front of the kitchen magnet, put it in front, you can actually see it changes values. And take it off, and put it back on. See that it fluctuates. Go ahead and pick it off, and it's actually fluctuating the z-axis because that's what it's picking up. Now I face it in probably this way. So this is the x-axis. If I point it in this way, it should change the x-axis values. I move it away, it should be large again. And then for the y-axis, if I just do it, say this way, move the magnet this way, it should increase the value. There you go. And go away, it goes back to the lower value. And then for accelerometer, if I go ahead and just move this to the side and tilt it, you'll see that the y-axis is now receiving the Earth's gravitational acceleration, so the y-axis is getting the larger value. Moving to the x-axis, you can see that it gets it in the negative value, because if I'm facing the other way, then it should be the positive way. So it's face it like this, then it'll get the positive acceleration. And I can go ahead and just shake this around a lot, and it'll fluctuate the acceleration here and there. So that's it. So we've proven that we can get the gyroscope to work and got the accelerometer and the magnetometer. I'll leave it to you to write the code to interface all three at the same time. That'll be a challenge for you to figure out. And also, if you want these numbers, you can actually calibrate them accordingly. So on the specification sheet, it'll tell you what each number means, so how to actually scale it accordingly. Typically, these values are it's roughly in the millig's for the accelerometer data. The magnetometer data is in a couple of gauss for each value. So you can go ahead and do that yourself if you want to go ahead and get a more accurate value, because these are just numbers that kind of have a general representation of what the acceleration is and what the magnetic field strength is. But you can go ahead and do that yourself, and I go ahead and challenge you to go ahead and do that. And that pretty much covers everything for the SPI tutorial, and just have fun with this sensor.